Hello student, let me start now with the third class of electrostat. Initially, in the first class we discussed the properties of electric charge like conservation of charge and quantization of charge. I hope this is understood, that two topics. Now, after that we discuss how to develop charge in an object by induction method. After that, we discuss how to calculate force between 2 point charges, and this is done by Coulombs law. So we discuss Coulombs law up to this format: F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, meaning this format gives the force between 2 point charges. Now be careful, this law is valid in this form directly to calculate force between 2 point charges. Point size charges, meaning big size if available, charge if of bigger size or bigger object. In that case, we must take help of calculus. How to use calculus we will discuss later on. Just you have to continue with the classes. Now, if 2 point charges, say Q1 and Q2, separated by a distance r, is placed in air, meaning medium between them is air or vacuum, in that case force is given by the constant 1 by 4 pi epsilon naught Q1 Q2 by R square. Already in the last class we discussed, if some other medium present with epsilon naught, we have to use a dielectric constant or the relative permittivity of the medium. In that case, force in a medium between the two charges becomes 1 by 4 pi epsilon naught k Q1 Q2 by R square. This k can be replaced by 4 pi epsilon naught with epsilon r. What is epsilon r or what is k, the dielectric constant? We already discussed this in the last class. Now I want to proceed further. To calculate force between them, this is the formula if they are kept in air or in vacuum. Now 2 point available. This gives us the magnitude of the force only. Direction comes from observation. Say for example, both the charge is positive or both the charge is negative, then there will be repulsion because similar charges repel. So in that case, Q1 will be getting a force like this and Q2 will be getting a force like this. Value of the force here and value of the force here will be same. It is same, we can say, according to Newton's third law, for every action there is equal and opposite reaction. So whatever force acting on Q1 because of Q2, same is the force acting on Q2 because of Q1, just they are in the opposite direction. Clear? By chance, out of the two charges, say Q1 and Q2, say any one positive, the other one negative. Here no sign written, meaning both positive. If both negative, then also idea same. Now one positive, other one negative. Because of that, there is attraction. So Q1 will be attracted in this side. Similarly, Q2 also attracted in this side. In both cases, value of the force will be given by this formula. So be careful, at the time of calculating value of the force, we never consider plus or minus sign of the charge. Instead of that, we will draw that direction. Accordingly, as discussed, I am going to show some other example also. Once this is drawn properly, you can very easily get the total force, because force is vector quantity, their addition or subtraction we can do very easily. I hope no difficulty in that. Now let me show some question based on this point charges. My advice is I am going to explain the question and you should write the question first. Clear? So keep yourself ready with pen and paper before start of my class, before you come to the video, and once you are ready with this, so please write the question first. So question is, you should write 3 point charges, each of charge q. I am repeating it, 3 point charges, each of charge q are placed at the corners of an equilateral triangle of side L. I am repeating it, 3 point charges, each of charge q are placed at the 3 corners of an equilateral triangle of side L. Find the force acting on anyone due to others. So if you draw this one now, say according to question, 3 point charges present. Say these are the point charges, each of charge Q as written in the question. They are separated by a distance L, written equilateral triangle, so side L in each side. So automatically the angle is available among them. Angle in each corner is 60 degree. As each charge Q, no no mention of sign of the charge, so you have to consider all positive, no sign meaning positive. Now how to calculate force acting on the charge? Say I am looking at this charge. This Q charge, because of this one, will be getting a repulsion in this side, because similar charges there will be repulsion. Of course this charge also will go in the opposite side, but none is asking what is happening on that. We are concentrating on this charge, meaning what is happening on this charge to be measured. So force acting on this one, say I am writing F1. Similarly, because of this charge, as they are similar, there will be a force in this side, say I am writing F2. Now what is F1 or what is F2? In this case they are same. Why? Because value of the charge is same and distance also same. So we can write 1 by 4 pi epsilon naught Q into Q, so Q square by the distance, so L square. Question was 3 point charges are kept at the corners of an equilateral triangle of side L. We have to calculate force acting on anyone due to others, meaning other two. So what is F1 calculated? Similarly F2 also same. Their direction discussed. This Q considered by me is repel in this side. This Q, because of the other charge, gets repel in this side. So it is getting two force, and angle between the two forces 60 degree. So if you are looking for total force, then F equal to 1 by 4 pi epsilon naught. How to get total force now? 1 by 4 pi epsilon will be common. One force F1 in this side, one force F2 in this side. So total force I am going to measure. I am writing net force. It is under root of F1 square plus F2 square plus twice F1 F2 cos of theta. How to get? If any two vectors present A and B, if angle between them is theta, then the resultant force is under root A square plus B square plus twice AB cos of theta. So I am writing F1 square and F2 square plus twice F1 F2 cos of theta. This theta is 60 degree and value of F1 F2 same. As value of F1 F2 same, meaning the same value, so if you write all this value, we can write outside because all carrying square term. So F1 F2 all same, so I am writing all F1. So it is now F1 square plus F1 square plus twice F1 square cos of 60 degree. F1 square present everywhere, we can keep it outside. Cos of 60 is half. If you write cos 60 half, half and 2 goes cancel. So it becomes under root 3 F1 square. F1 square plus F1 square, meaning I am writing all F1, you can write all F2 because their value same. Cos 60 half, half goes cancel, 3 F1 square, so it is root 3 into F1. Okay, I hope no difficulty in that. So answer becomes root 3 times of F1. F1 is this 1 by 4 pi epsilon naught Q square by L square multiplied by root 3. So we can write the required force as root 3 times Q square by 4 pi epsilon naught L square. So this is the force acting on the point charge here because of the other two. If someone asks you the direction of this force, we can very easily do direction of this force, as these two forces are exactly equal according to triangle law. Triangle law or parallelogram law, we will get the direction of the resultant easily. I am drawing it once more. The charge Q here, the other Q here, the third Q here. We are calculating force on the charge here. So a force in this side and a force in this side. So their result, as they are equal, their result will pass through the middle. So that is the required force. It will pass through the middle. Meaning as this total angle was 60 degree, this angle is 30 degree. So resultant will be in this direction. I hope this is understood. No difficulty in that. At the time of doing calculation, be careful with direction. Clear? Let me discuss the same question by considering one negative charge now. Initially, all the charge is positive. I am considering another question now. My advice is you have to write the question as I am saying, because it will take some time to write, and in that way you can understand the whole thing properly. So now the question is, I am considering again 3-point charges. Here also I am considering 3-point charges. Only difference is, in the last question I am considering all point charges positive. Now the point charge here is negative and other two positive. All positive or all negative gives you similar kind of result. Now this minus Q, because of the Q here getting one attraction in this side, value of the force say F1. The Q here, because of presence of this minus Q, that minus Q because of this Q will get one attraction in this side. This is also F1. If you consider same equilateral triangle of side L, and automatically all side equilateral, so this angle is 60 degree, this is also 60 degree. So here also the force acting on them is exactly equal. They are in direction as drawn. Minus Q gets attracted by the corner charge here, and the same minus Q attracted by the corner charge here. So in this case also, total force, the required force will be same as this one, meaning root 3 times Q square by 4 pi epsilon naught L square. Resultant will pass here again to the middle. We will get it by the parallelogram law. So this is the direction of the resultant. So resultant here exactly in the same way as the last one. In previous case all the charges similar repulsion, so because of the repulsion it wants to goes away. Now all the charges are giving attraction, all the two charges at the base, so that minus Q getting a force now in downward direction, meaning towards the base. I hope you understand the idea how to calculate force between 2 point charges. Some other example I am going to explain now. Clear? This is one example. Let me go for one other example now. Say for example, now I am not going to consider 3-point charges. Say I am going to consider 4-point charges. Say a situation, say 3-point charges idea now over. I am considering 4-point charges. I am considering 4-point charges. Say all 4-point charges equal in magnitude as well in nature, all positive say, and they are at the corners of a square of side L. I want to show how to calculate force acting on anyone. It is easy. By chance these charges are different in magnitude, how to do? I am showing the next question. Okay, first be careful on this one. So if you are interested in writing the question, I am saying the question to you. It is like this. 4-point charges are kept at the corners of a square of side L. Each charge is small q. Find force acting on a point charge at any one corner due to the other 3. I am repeating it. 4-point charges, each of charge q, are kept at the corners of a square of side L. Find force acting on the point charge at one corner due to the other 3. Now look at what to do. Say I am considering this corner. You can consider any corner. I am considering this corner. This Q, because of Q here, is getting a repulsion in this side. Why repulsion? Because similar charges. This Q also gives a repulsion. Repulsion from this one and repulsion from this one will be same. Why? Value of charge is same as well distance also same. So this force, if you write F1, it is q square by 4 pi epsilon naught L square. If you write force in this side, then also it is F1 because magnitude same, only direction different as discussed, q square by 4 pi epsilon naught L square. If you consider force from this corner, from the corner distance up to my considered charge is different, because this distance if L, this distance if L, according to Pythagoras principle, this is root 12. Root 12, let me write clearly. So because distance is different, force in this side different. So what is the force now? I am writing F2. What is that? 1 by 4 pi epsilon naught q square. Distance is root 12. Don't forget to square it. So all the forces measured. Now forces are vector quantity. We have to find the resultant. So how to find the resultant? As F1, this F1 and this F1 exactly in same magnitude, exactly of same magnitude, resultant of these two will pass through middle. That resultant with this F2 we can add. So what is the resultant of F1 here and F1 here? I am writing result of F1. So result of F1 is only F1 I am counting. It is under root F1 square plus twice F1 cos of 90. I am repeating it. F1 here and F1 here of same magnitude. Angle between them is 90 degree. Why? Because it was a square. So cos 90 is 0. No need to write F1 square and F1 square. It becomes root 2 F1. I am simplifying it. This is the value of the first two. F1 here and F1 here gives us root 2 F1. F2 present in this side. So required force is simply two vectors in the same side can be added in ordinary way. It is F2 plus root 2 F1. So let me write F2 carries q square by 4 pi epsilon naught root 2 L square on squaring twice L square. Then root 2 present. What is F1 written here? It is q square by 4 pi epsilon naught L square. I hope this is clear. In that way, q square by 4 pi epsilon naught L square common. Here it is 1 by 2 and here it is root 2. If required, you can take LCM and you can simplify it further. This is the idea how to calculate force acting on point charges. If by chance charges are different, I am going to discuss separately. Clear? Once this idea known, we are capable of doing calculation for force acting on a particular point charge due to other point charges present. At the time of doing calculation, be careful. Similar charges shows repulsion, opposite charges shows attraction. Value of the force when you calculate, no need to write plus and minus sign of the charges, write value only, like 1 by 4 pi epsilon naught q1 q2 by square of the distance. And at the time of calculating total force or at the time of showing direction of force only, you consider the direction. I hope this idea is understood. If any difficulty, you can contact me. So my advice is go to the class once more, try to do the problem from your side, in your copy, in your own handwriting, then you will get the whole idea. Thank you. We will meet in the next class.